All right, so our caching is all done. And now we can just slide through this super easy. It took like almost a minute per frame for some of the later frames of my computer, so this is a breeze. It would be nice to see it in action though. If we switch the style here to smooth shaded from smooth shaded with wireframe, we'll probably get a little bit of a better sense of it. I'm going to let this flipbook run for a moment here, and then we can review it. And that was easy. And there it is. So that is more or less what the ocean's surface is going to look like. And again, what we're targeting is for all of this interesting action here, that will still be rendered as such, but anywhere where it's still this kind of flat, undisturbed area, we're still going to have that render in the same manner of the ocean. And then we'll just, composite them on top of each other later. We can see that it works. We see there's no missing frames or anything like that. Again, especially if you had been using the rebuild, and some of the other flattening things can cause it to error. So it hasn't errored, it looks good, and now we can move on from that. Out over here, we can make a render node for this, because this, again, really is what's going to be rendered as far as our splash layer. So we'll say render ocean splash exterior. Make that red. We'll jump in and we'll say object merge. And what are we going to object merge? Well, let's put a null here to make this the surface. Like so. Now, it should be noted that when you render something in Houdini or in Mantra, and let's say it says we're rendering this node, which is object merging this, and what is that? It's a whole bunch of points and primitives and stuff. It's going to save that to disk when you do the render, and then render that from the disk. Because Mantra is really a separate program entirely that starts up and has to read its data off the disk. What you can do to help it out, especially if this is being done on a render farm, rather than have all 120 frames read this cache and then write it to disk again so that Mantra can get it, you can actually tell Mantra to just read this file itself, because it's already all here. We don't modify it any further on the way to the render. So go to load from file and say load packed disk primitive. If I middle click and hold now, it'll just be one packed primitive disk. We can still see it if we want. It says bounding box right now, but if I say full geometry, there it is. So we can still see it. We just can't modify it anymore, or at least we can't modify it until we just convert it back to being polygons. So why read it as a packed disk primitive and then convert it right back to being polygons and points again? Well, because at this point, it's still a packed disk, and that's what this is reading. One packed disk. So now when Mantra renders this node, it's just going to find this, which is just going to point right to the bgeo.sc file on the disk that it needs. And it'll just render much faster because it won't have to save all this data out first. And again, especially, accumulated over 120 frames, that time adds up, and especially if they're particularly high resolution kind of volume files or whatever. So this is just a nice bit of optimization. So that's fine for the exterior. We can even give it the shader that we've been using. So ocean surface. Yeah, I click it and it's not selecting it, but it is actually selected, as you can see. Another weird bug. So it's the same shader that the regular flat plane has. Interesting. We're not going to render it yet, though. It's not ready to be rendered yet. If we tried to now, it would be just applying the ocean displacement to everything, even all this nonsense here. So we'll deal with that in the next chapter when we talk about the masks. But for now, just like we have the exterior here is one flat thing and the interior is this kind of volume thing, same is going to go for this. This is the exterior, and we're going to make it come down the same amount as the other one, and also actually stick out a decent amount as well. So to do that, we'll need to extrude the edge, the border edge, around the side first. Fortunately, we can do that with the group node. Now it's important when we place this group node here to turn off this base group thing. By default, with this being on, it's going to group everything that's incoming. So turn that off first. Then go to group type, go to edges, because that's what we're trying to grab. It's just the outside edges. Call it border. And then for include by edges, you can just go right on down to unshared edges. And that'll do it. That'll probably do it. And as you can see, it does. We just have highlighted the outside edges. Unshared edges meaning typically every edge has a polygon on both sides of it. The only ones that do not are the ones that are on the, let's say, edge, the border of our geometry. Where this like has a polygon on one side of it, but nothing on the other. It's open. So that's probably good. In most cases, this will probably be right. The only problem is that potentially it won't be. Could be errors in the meshing of this. There could be holes here and there. I mean, there shouldn't be, and there probably won't be, at least on most frames. But just in case there are, we want to do this. Let's make another group before that happens and say, find me all the points. I'm still going to call this border. Find me all the points that are within a certain bounding box. And as you might guess, that bounding box is going to be our old friend, which is the tank. So go find your tank. Oh, it's making all my particles again. So find the tank, put it here, center, put it here. So that will be literally everything, just about, except it goes a little bit further out. Because remember, we're doing our flattening business later on. When we did this, it extends 1 unit out past the edge of the box. So we have everything inside the box right now. And what we're actually going to want, oops, clicked on the particle fluid by accident. What we're actually going to want is everything outside of it. I want to limit where this looks for the border edge. I don't want it to consider every edge in here. I want it to only consider where we know, just by looking at it as a human being, where it probably is. So give me all the points inside, then do a group combine, and say my border group is equal to everything but itself, which will essentially invert it. So now you can see it's only selecting the points on the outside. And now you can do another group thing called a group promote, the tour de force of all the different group things. These actually all used to be in the same group node back in the day, so it's kind of funny that I am resorting to using them all again. So convert the border to edges. So now these are going to be our only candidate edges. And we're going to do that by saying this normally is going to replace anything called border. But now that we already have a border edge group coming in, we can say intersect with it. So the result after all that is the exact same thing. But now we can at least sleep safely, knowing that, or I should say sleep comfortably, knowing that our edge group is being safely calculated. At least a much better chance of it being right. I don't think we're going to ever get little holes in the meshing process out here. We just might get holes in the meshing process. I've seen it happen before, and that's the thing. My experience of frustration and wondering why things aren't rendering correctly or things aren't being generated correctly, it's because of that. It's because holes can show up. And there you go. So now we're very sure that our border group is good. We can put a poly extrude down, and the poly extrude will be that border group. And we're going to skip these various distance, inset, twist, all that stuff. Skip all the way down to the front transform. This is kind of the brute force of I know exactly which direction I want it to go in. I don't want to rely on the normals or the orientation of the faces or whatever. I want it to move globally, which is important also, down. I know exactly what I want it to do. How far down should it go? Well, remember when we did the ocean grid setup before? and we had this extrude volume, make it go down 5, that's how far it should go. So just link those two here. So it goes down the same amount, -5. That's cool. We want to have the side group be written out. So these new polygons that we just made, I want to work on them in a minute as well. But for now, let's do a polycap, like so, or polyfill. Have it do single polygon. And I actually should have said, I guess it's too late now, but when you do a polycap, make sure it's set to single polygon already. I guess that's what it is. If you type polyfill, it's not set to that by default, but if you type polycap, it changes that to single polygon. So make sure that it's set to single polygon, otherwise it can make your computer crash. Because it's going to try to make like a billion little polygons down here, and it can take a long time. Anyway, so there you go. We got a nice volume now that where the roof of it is. This is what this is. This is a cube of water now where the surface of it is being disturbed in this way. And we actually want to do one more poly extrude. Because this is going to be the volume of our, the volume that's inside that gets shaded. If I'm looking at it and I have a ray coming out from the camera, and let's say the ray goes right here at the corner, it's going to quickly pass through this volume. It's not going to see much volume at all as it passes through and out the other side. Here, it's going to go through a great thickness of volume, but here it won't. So we need to make this, just to make it perfectly good and right, we want to make this actually extrude out even further around the sides. Because this is only going to be rendered as a phantom object anyway, it's only going to be seen through this top surface area. So it doesn't really matter how big it gets. It's not going to shade any of that primarily. It's only going to see it through the square here. Hopefully, that's a little abstract, but hopefully that makes sense as we do it here. So what are we extruding? We're extruding just the outside surfaces, which are the ones called extrude side, because we told it here that we wanted to save the side. And we want to, same thing, we want to use the front transform here. I don't trust this distance thing. The distance thing will probably honestly do it, but we're relying on the normals and whatnot for it to do it correctly. So instead of relying on that, just say transform extruded front, give it some amount of extrusion that makes sense. We'll say, or rather do it under scale. I'm going to say 1.2 in the X and 1.2 in the Z. Obviously we don't need it to do it in the Y. This will work well enough until later. Actually, it's working pretty well overall, because we could just keep it. All right, I guess it's fine. I was going to say I think we need to put the centroid. Oh, because I did have it local here. If I do it as global, it's going to get weird by the end of it, say, because it's doing it from the origin. But local space is working fine, so I guess I won't say what I was going to say next, which was to put the centroid X and Y here. But apparently we don't need to, so forget it. Great. So this is actually pretty fast to calculate, certainly much faster than when we did the particle fluid surface here. Nonetheless, we are going to cache this as well. So go to manual, grab the surface here, paste it down here, say interior. Same thing, we still want to be doing the pack disk primitive. We still want to be loading from disk. We still want to have a null after it. We'll call it interior. And we can come back into auto update mode now. And let's cache these. Oh, let's put it in the dependency network area first. Oh, we gotta do our surface one too. So fetch surface. Obviously the surface relies on the compressed fluid sim being run, and of course the interior relies on the surface being run. So like I was saying before, if you change some settings on your sim or whatever overnight or over a few hours, you could just say run this one, and it will first run this, then run this, and then run this. So it's a really cool way of automating this kind of stuff. But anyway, let's go grab, or let's just click on surface here and say which one do we want. We want in our out ocean splash, and it's nice. It just shows the the ones with render operators inside them. For the surface, we want the file cache surface render, like so. For the interior, we want the interior render, like so. Just double check to make sure that it's, the name of the node matches what you expect that it is. That's cool. I'm gonna disable these and then do our interior cache and make sure that everything looks how we expect it to.